going to discuss, today we are going to discuss about, again we are going to continue from where we left the other day. So we are going to talk about again establishing the product function. As I told you in the previous class, this is a very important part of product design. So we will be spending at least another 2-3 sessions on establishing the product function. Today we are going to concentrate on certain terminology which will enable us to arrive at what is known as the functional tree of the product. The functional tree of the product. Now there is no one-to-one mapping. Later on you will see that the functional tree is going to relate very well with the actual product architecture also. So what we are going to do today is to learn few definitions and the basic approach of how we are going to attack the problem of establishing the product functions. Is it okay? Next slide is on function. First of all, let us get the definition of a function. Essentially, what we are trying to look at is what are the expected functions to be performed by a product. This we may have to list down very clearly, because that is what we are going to accomplish in the product design activity. So first of all, we should clearly understand what we mean by the term function. A function of a product is a statement of, please understand, a function of a product is only a statement. It is only words. A function of a product is a statement of clear, reproducible relationship between the available input and the desired output of a product. And it is independent of any form. Is it okay? First of all, I'll explain what it is. First of all, it is a statement. Please understand, it is only a statement. Function of a product is only a statement, and it is independent of form. We don't know how. It is not a drawing. Please understand, function of a product is not drawing. We are not attempting to generate the drawing. We are not attempting to generate the physical product. No. What we are trying to do is, we are trying to write a very clear statement. What does that statement say? It says something about the relationship between the input and the output expected in a particular product. Suppose I am talking about a television. Television is what is the product that I am talking about. Is it okay? When some signal is picked up from the cable, the television is supposed to produce a very clear-cut image. This is the basic functionality of the television. So I say, you take this particular signal through the cable and you produce a high quality image. What is the input to the television? It is the signal. What is it? What is the signal format? Those things will come when I go deeper. Okay? What is that signal format? Is it an analog signal or is it a digital signal? Okay? If it is an analog signal, there are various formats available. You have PAL, you have NTSC, you have various other signal sources. If it is digital, then again, what are the digital signal sources? Can somebody say? What you are talking about is file format. Okay. You think about it. There can be digital signal input to there can be digital signal inputs to a monitor or a display device. Essentially, we can make it more general. Nowadays, there is a lot of commonality between your computer monitor and a TV system. With the advent of LEDs, okay, there are a lot of commonalities between your computer monitors and televisions. So the plasmas are going to bring them closer together. So what we are going to talk about here is what is the input and what is the type of output I am going to have. So this is the relationship between input and the output that we are talking about. And this statement must be clear. There should not be any ambiguity. It is reproducible. The relationship must be reproducible. It is not that at one point of time I give a particular input, I get the output. I give the same input at another instant, I get a different output. No, that is not acceptable. So, the function of a product is a statement of clear reproducible relationship between the available input and the desired output of the product. It is independent of any particular form. I am not bothered about any drawing. I am not bothered about any model at this point of time. At this point of time, I am satisfied with a very clear statement. This is essential step in product design because you have to very categorically state what we want to achieve. If there is an ambiguity in that statement itself, then probably I may not go anywhere. So there must be clarity in what we want to achieve in this particular product, and that is the purpose of arriving at a very clear function statement. Now, next I am going to see few more definitions. So what is the product function? The function in general is what we saw earlier. Now we are coming to more concrete terms, what is known as a product function. The product function is the overall intended function of a particular product. What my product as a whole is supposed to do. And in a way, it is what the product is supposed to perform. Now this definition will become clear when you go to the next thing. You have to study the definition in contrast with what I call it as a sub-function. The product function is the overall content of the product, overall delivery of the product rather than content. It is what the overall product is going to deliver to me. Is it okay? Now, sub-function is a component of a function. The overall delivery cannot be achieved in one stroke. It is achieved by many sub-functions performing together, and that I call it as sub-function. Now, why all these splitting definitions? Now, let us see the overall picture first. What are we trying to do? We are talking about something called functional decomposition. Please take it from me, any product is a complex piece of machinery. And anything that you can think of is a complex piece of machinery. It is supposed to do a particular function, but this particular function can be realized only when many subsystems work together in a synchronized fashion. Take the simple case of a bicycle. Okay, what is the purpose? What is the function of bicycle? Can somebody give me can I go back to the, sorry, you better use, no, yes. Now, can somebody give me a functional statement? What is the function that we expect from a bicycle? Bicycle is a product, I think all of us understand, there is no ambiguity about it. Suppose you are designing a bicycle, you are going to design a bicycle. I want you to give me a function statement. What is a bicycle supposed to do? You are going to commute. You are giving good, okay. Commute from one place to another. Or rather, bicycle is supposed to facilitate commuting from one place to another. But you are not specific. A car does that, an aeroplane does that, a ship does that. Beautiful. Very well said. I would only prefer to refine it. Okay. A system which is meant for commuting from one place to another, okay, using muscular energy alone. Is it okay? Again, I consciously, I took it from him and then I consciously introduced some ambiguity. Because these ambiguities are what you have to eliminate when you arrive at a product statement. You understand? First, he said commuting from one place to another. Fine, what is the difficulty? Everything helps me in communicating. An aeroplane helps me in communicating. Commuting, not communicating, commuting. An aeroplane helps me in commuting from one place to another. He said, it is, what is the exact phrase that he used? Manual. I am not very fond of that term, so I use muscular, a system to commute from one place to another using muscular energy alone. Have I defined the functionality of my bicycle? No. A boulevard is also a system which uses purely muscular energy. He will object. Sir, I didn't say muscular. You only said muscular. I said manual. Okay. He might object, but still. So, it is a muscular energy from human beings. A system to commute from one place to another using muscular energy from human beings. So that is the functionality that I want to achieve. So that is the function statement. It should be very generic. At the same time, it should exclude all the unwanted things. Does it exclude aeroplanes? Does it exclude aeroplanes? Excuse me. No. Was my definition satisfactory? Did I exclude all the other unwanted things? Is it specific enough? But still, it should provide me scope. See, the point is, I should not start with the functional statement. I will say what it should not be. Okay, a two-wheeler. It should not be like a two-wheeler. Okay, to be driven by human beings. First of all, why should it be a two-wheeler? Why not 3, 4, 5, 6? Why not a single wheel? The point is, you should, because when I call it myself as a two-wheeler, the first instant itself, okay, I put an unwanted restriction and I limit the scope for further innovation. So a function statement should be generic enough with only excluding the really unwanted options. It should be generic and it should provide scope for innovation also. Okay. Now having decided the overall function, it should use only the muscular energy from human being as inputs, and it should help me in commuting from one place to another. Okay. Having decided this, I should come to what are all, can we please go back? Yes. I should go to next please. What are all the sub-functions that are to be performed if I want to achieve this particular function? So to commute from one place to another with human muscular energy, what are the things I need to do, human being? Now first of all, I need to have a comfortable arrangement in which the human being can sit and insert the power. So that talks about a frame. Please remember, I am talking about only functions now. But please remember, functions are not achieved in thin air. Functions are achieved by using some physical systems. Functions cannot be realized at the stroke of a magic wand. No. Functions are realized by having some physical systems. So later on, I am going to talk about a mapping between the sub-functions and subsystems. If my total function is delivered by my total system, my product, my sub-functions are going to be facilitated, are going to be realized by using the subsystems of the product. Now, the sub-functions are the component of the function. So, what are the components? The first component that I could think of while designing what are we designing now? No. Bicycle is the name that you are going to give after you finish your design. What we are designing right now is, because when you say bicycle, what does it mean? Bi means two. It is a two-wheel cycle. That is the name which you gave at the end of your design process. What are we designing right now? Again, I am emphasizing this point. The moment you arrive at a function statement, all that is going to drive your subsequent action is only the function statement. So, what is the function statement now that we have accepted? A product which helps me in commuting from one place to another, that uses only human muscular power. Or man-driven, a man, or then people may object, why not women? Okay, a human-driven, okay, system for commuting from one place to another. A human-driven system for commuting from one place to another. Fine. So it should have a provision in which the human being can sit and then apply the power. Number one. Number two, should it have a steering system? Yes. When you are talking about commuting from one place to another, I have to avoid certain obstacles, have to direct the way in which the travel takes place. That is possible only when you have a steering. So it should have a, what are the sub-functions that we are talking about? First, provision to sit and exert power. Let me not commit as sitting. Provision to exert power. I am not bothered whether he is sitting and exerting power, whether he is standing and exerting power. No. Let me not bother, because I am providing scope. I am enlarging my scope. Okay. There must be a provision to exert power. Power needs to be transmitted. Is it not? The power exerted by the human being, it needs to be transmitted to the wings. Of course, when I commit the word wheel, I exclude sledges. I don't know whether you're following it or not. When I say wheels, I am excluding sledges. What do sledges do? They slide. Okay, but sledges cannot be operated on roads. They can only be operated on ice or frictionless surface. So when I come in wheels, it is fine because you can exclude the sliding, and you are going to have only rolling. Okay. Then steering. Now steering is another functionality that is required. Now anything else you want? Controlling the power.
Gear.
So gear is please remember, I would prefer his answer because he is talking about controlling power. Of course there is some mistake in it. I'll come to that later. Gear is a product, not a function. We are talking about some functions. So you should not talk about a gear system. No. Is it controlling power? Does a gear control power?
Control speed.
Is the power increased or decreased? What is increased or decreased in a gear?
Speed.
No, sorry.
Speed.
Yes. It is the speed which is increased or decreased, or to be more precise, I mean, it is equally true to call it as a torque. It is increased or decreased. Power almost remains constant. Power will never increase. Unless I put in more effort, the power will not increase. If I pedal very fast, the power is increased. If I pedal very slow, the power is reduced. So the power is controlled by me in a bicycle. Okay, if you want more power in a bicycle, what I have to do is, I have to slog more. If I want less power, I can leisurely pedal. Power is controlled by me alone in a bicycle. What the gear does? I deliver so much of power, that power consists of dash into dash. Can somebody fill up the blanks? Mechanical power, I have told in this class, I remember so well. Mechanical power is a product of dash and dash. Yes? Somebody said it?
Speed and torque.
Speed and torque. Mechanical power is a product of speed and torque. What the gear does is, it does some trade-off between speed and torque. If I am traveling on a level road, what I can do is, I need not have so much of torque because it is only the friction that is to be overcome. So the speed can be increased. So the same power, the torque supplied is reduced, the speed supplied is increased. Get it? If I am going uphill, okay, the torque required is so much. So the speed is reduced, the power remains. So what the gear does is, it does a trade-off between, trade-off na puriyudunga? Trade-off is, to put it in Tamil, trade-off na vittu kudukurathu. Adukku edala or balance. Edhu edala balance? Speed ku, torque ku edala or balance. That is achieved by your gearbox. So what can I write? Trade-off between speed and torque. Some trade-off between speed and torque is achieved by means of a gear. That comes later. I'm talking about the functionality. When will I require this functionality? When I'm going uphill, I will require this functionality. Some trade-off between speed and torque I will require when I am traveling uphill. Now what does it require?
Suspension.
What other functionality you require?
Suspension.
To bring it to a stop. If it is going to hit somebody or when you want to, when you have reached your destination, okay. 5 is, okay, how can I put that functionality?
Brake.
Brake is a product. Okay.
In this case,
Ability to stop. Anything else you require?
on bell.
Pardon?
Release the product. Bell.
Fine.
Or
So he is, please remember, now what he said here is, he said bell. Now, what we are trying to do is, it is easier, let us practice this. What we are trying to do is, from the product, we are going to the functionality. But at the end of this course, what you should be able to do is, you should be able to go from the functionality to the product. Because you know a cycle. So from the cycle you are thinking of the functionality. We are doing sort of reverse engineering. But what you should also learn is to do the forward engineering. From the functionality you should arrive at the product. So what is the functionality that you want? You want to communicate with the rest of the system. What is the purpose of the bell? The bell is a communication device in the cycle. A horn is a communication device in a car. What does it do? It tells the other people on the road that I am coming. Move aside. Do you understand? So, some communication system has to be put in place.
what direction is that?
Some communication system needs to be put in place. So these are all called the sub-functions. What is the overall function? Overall function is commuting using human power. Human power alone. Commuting using human power alone. What is this? This is the overall function. And what are these? These are sub. Now how did we do this? We took an existing product and then for an existing product we wrote the overall function and the sub-functions. But please remember, in our actual practice as design engineers, what we have to do is, we will have the overall function defined, the product will not be known, we will define the sub-functions, we will realize the sub-functions using sub-assemblies, put them together, realize the product, realize our requirement. Yes?
Suspension is a product or function, sir?
Pardon?
Suspension.
Fine. Suspension system is a sub-assembly. What is the function? It's a very good question. He asked me, suspension, is it a product or a function?
Function.
Because it is a noun. Now, a suspension system, let me clarify. A suspension system is a product. What function does it provide? It reduces the vibration, not function. It reduces the vibration. It absorbs energy. The shock energy is absorbed and then dissipated by a good suspension system. Any suspension system, the objective is to absorb suddenly delivered energy and then dissipate it. when you travel in a bicycle, if you are getting into a run, ஒரு பெரிய பள்ளம் இருக்கு, அந்த பள்ளத்துக்குள்ள போய் வந்து bicycle விழுது அப்படின்னா, then lot of energy is supplied to the bicycle. Two things must happen. All this energy must be absorbed first. The second thing is, the absorbed energy must be dissipated. One big problem is the energy cannot be destroyed. Please understand. The energy cannot be destroyed, nor it can be created. That is the whole problem. That is the biggest problem also in mechanical engineering. Please understand. When you are talking about a suspension system, that is the biggest problem. Whenever a shock energy comes, two things must happen in any vehicle. First of all, that energy needs to be absorbed, and that energy needs to be dissipated. So, what is the function that we should talk about? Energy absorption and dissipation. Energy absorption and dissipation. Well, what do you mean by energy absorption and dissipation? See, whenever a vehicle falls, how is it realized? To understand this functionality, let us deviate and then see how it is realized. Okay? When your vehicle falls, suppose, let us go to a two-wheeler. That is more realistic. Because large amount of energy absorption is required only in a two-wheeler. Okay? So, because the velocity involved is more, the mass involved is more. Okay? So, suppose you have your bike, okay? You fall in a run. Then what happens? Large amount of energy comes into the system. What happens immediately? That energy is to be absorbed. How is it absorbed? It is absorbed as the strain energy of the springs. Sorry. So you have, any suspension system will have a spring. That spring immediately deforms. When the spring is deformed, the energy is stored as strain energy in the springs. Now subsequently what should happen? This energy which is absorbed by the spring, it is to be dissipated. So, how is it dissipated? In a two-wheeler? In a typical bike, what happens is, there is a piston cylinder arrangement. The piston is made to move inside an oil-filled cylinder. So when this piston moves through the oil-filled cylinder, all the energy is converted into heat. I don't know whether you are getting my point. Suppose that is called a dashpot. You have, many of you might have changed oil in your bike suspension. Have you ever changed oil? Huh? You have to change periodically the oil in your suspension, in your bike suspension. The purpose of having an oil there is to, the piston has to move against a viscous oil, in that process dissipating the energy absorbed. If you don't have that arrangement, what will happen is, your vehicle will keep on oscillating, your seat will keep on oscillating. Because the spring has absorbed. Okay, when the spring, it will dampen on its own, but before that, you will experience a lot of inconvenience. You will be thrown up and down if your dashboard is not working. So, what functionality to be achieved is energy absorption and dissipation. How that is achieved is by means of a spring and a dashboard. Now, next slide please. Now, I may have to go quickly because I have one more agenda today. Now, the abstraction, see what we have to do is at this stage, you have to view the thing in a general fashion, not going to the specific details. Specific details will come later. So product design at this level, it has to be viewed as an abstract entity. So abstraction is nothing but you ignore what is specific. You ignore what is incident. You only concentrate what is general and what is essential. So that is the process of abstraction, and that has to take place at this stage of product design. Next slide, please. Now here I have to very clearly, any product design is carried out with a lot of constraints. Any product design is to be carried out with a lot of constraints. What are the constraints? Constraints are certain overall guidelines within which I have to operate. If I violate the constraint, there may not be any taker for my product. Do you understand? Suppose I want to produce a basic cell phone. A basic cell phone. What is the objective? I want to provide cell phone to everybody. Of course, everybody has a cell phone now. Okay. Now I want to design a basic cell phone that can be bought by everybody. Is it okay? So what is the constraint here? The constraint here is the cost of the cell phone must be less than 250 rupees. Less than 250 rupees. That is, then only the product has a meaning. Is it a function of the cell phone? No. Function of the cell phone is to communicate. Does it have anything to do with cost? But this is a constraint in my product design. Please take it from me, whenever you carry out any design, there will be a lot of such constraints also attached to them. Constraint you must clearly distinguish from the function. Okay. Constraint you must distinguish from a function, and you must give due respect to each. I'll give you an example. Suppose I want to design a bicycle that can be carried on your back. Yeah, I'm giving you an idea for a very innovative product. Imagine it will provide a lot of functionalities. If you can carry your bicycle on your back, probably you can commute from your house from Thiruvattiur to zoo through bus. The moment you get on from the bus, what will you do? You will unwind your bicycle, okay, pedal and then come to the classroom. Yes, and there is no issue of parking, it will save a lot of, it is a possibility. Please believe me, there are products which are available. There are bicycles which can be carried on your back. It's not, and what I'm telling you is not something new within quotes. Now, what is the functionality of a product? What is the functionality of this particular product? The functionality of this particular product is, okay, commuting using human power alone. That is one functionality. And a portable commuting device. A portable commuting device which is using human power alone. Now this product, it has a constraint. What is the constraint? The weight of the product cannot exceed 10 kg. 10 kg is the weight that you can carry without much of grudging. Okay, 10 kg is the weight that you can carry on your backpack. So the weight of the product should not exceed 10 kg. What is this? Is it a functionality? No. It is a constraint. If my product is not fulfilling this constraint, my product will fail. Now as I proceed with more cases, you should learn how to distinguish between a constraint and a function. Cost is a constraint. In many situations, cost is a constraint. In many situations, weight is a constraint. In many design problems, weight is a constraint. Foot space is a constraint. Okay? What is the size is a function, is a constraint, not a function. Size is a constraint. It should not be so huge. Okay, it should become it should be viewed as a constraint. So you should be able to distinguish between a constraint and a function. Now we have missed our product study for few classes. I consider them very important. Now today I have taken, because many students said it's not good enough, you take up small systems alone. We have talked about bicycle a lot. Okay, let us talk about something which is challenging from the engineering point of view. So I thought I'll take something which is really challenging from the engineering point of view. Okay, today the product that we are going to study is submarine. Okay. Now, what I am trying to teach, let me be very clear, I am not taking you a class on submarines. Last class we discussed about what was the last product study that we did? What? Oh, last class we discussed about jet engines. I am not qualified to talk about jet engines. My objective was not to teach you how jet engines work or how submarine works. No, that is not our intention. What our objective is, what are the design issues involved? Are you able to identify what are the design issues involved in a submarine? What is the difficulty in realizing a submarine? What is the difficulty? No, I'm not asking you a question. Okay, I'm putting the whole case studies into a perspective. I'm trying to put the whole case study into a perspective. The objective here is not to study submarine per se, but to appreciate what are the design difficulties in realizing a submarine. In realizing, because later on you should be able to identify, when you are posed to the design problem, you should be able to identify what are the general design issues that are to be addressed, so that you can solve them and arrive at an acceptable design. So what I am trying to teach is not submarine per se. I am repeating once again. What I am trying to teach is to identify what are the design challenges that a submarine design faces. Is it okay? Next slide. Now to achieve this, I have to have a historical perspective. Okay? To see what is underwater. See, the greatest quality of man, the greatest quality of humanity is curiosity. Is it okay? The greatest quality of human being is curiosity. The tragedy is many of you seem to have lost it somewhere. Let us go back, search it and get it back. If you lose curiosity, you have lost everything. By the way, curiosity is a name given to something else. Can somebody name it? I'll give a pen as a gift for this quiz. Curiosity is a name given to something else. Okay, I'll put the question in some other way. What is curiosity to NASA? Curiosity to NASA. No. You find the answer and come back later. The question is over. The quiz master has gone. Okay. Now, the biggest assert of a human being is curious. Man is always curious to know what is there. So, 400 years before Christ, Alexander the Great, he was very curious to know what is inside water. Of course, he is a king. You cannot ask him to jump inside and then see. See, this is the luxury of being a king. He wanted to see what is inside water, but still he is not ready to take a dive. So they designed a bottle. It is called a glass diving bell. They designed a bottle in which he can comfortably lie. So the bottle will be taken. They're taken to the river through a boat. Somebody will lower it. Alexander the Great can see what is inside the water, below the water level, and then he can be taken in. You know, that is the luxury of being a king. So this is incidentally the first historical trace of a submarine. You wanted to see what is underneath the water. What are the issues involved? Again, I am not saying it because I am a follower of Alexander, no. I am saying this because it addresses certain design problems. First, the Alexander the Great must be able to see through the water. So it should be made up of some transparent material. Number two, oxygen. The bigger challenge, it must be provided with oxygen. It must be filled with enough air. The people standing in the boat must pull him back in time. Otherwise, all of them will be executed for treason. You understand? They would have been charged with conspiring against the king because they would have killed the king. If they have kept him down for more than the permitted period, so he should be provided with enough oxygen. So this in a nutshell addresses the two important issues in any submarine design, that is the air and light issue. We'll come to it later because these are the issues haunting submarine design even today. These are the issues driving submarine design even today. The next slide please. Okay, this is another design in which Alexander need not lie down, he can sit comfortably under view. Okay, we don't know whether these products were realized, whether Alexander really sat there or lied there and then saw what is inside the water. No, we really don't know, but these are good conceptual designs. Please see, it is made up of transparent materials. We are able to see the person inside. That means it is made up of a transparent material. We really don't know whether these products were realized. Next slide please. Now again, there is something wrong. It is not 1960, I am sorry, it is a mistake. It is again, no, not even 1860. It should be much earlier.
1690.
At least some 300, 400 years back. Okay, I would comfortably bet it as 1660 or 1560. Rome. Okay. So you have here you have another. I show this picture because this addressed another important issue of submarine design. That is the issue of buoyancy. The basic difficulty in submarine design is, what is the basic issue in submarine design? Now you have to establish a balance between two forces. One is the buoyancy force, the other is the weight. Your engineering mechanics, very much the engineering mechanics that you are studying. Okay. A body continues in state of rest or uniform motion unless it is acted upon by a net external force. Is it okay? Now, so I have so this is the water level. So I have a submarine. So suppose I'm now interested in resolving forces in the y direction alone. I'm not bothered about x direction. Right now I'm not bothered about the x direction. Okay. So it can be I can do the analysis in one direction alone, forgetting about the other, and then do the analysis for the other direction, and then combine the two. This is called the principle of superimposition, which is a fundamental principle in mechanics. The mutually independent directions, x, y, z directions, they are called mutually independent directions. Many times we repeat the words without understanding the meaning. What is the meaning of being mutually independent? Correct. அவர் என்ன சொல்றாரு? ஒன்னோட ஒண்ணு சம்பந்தம் கிடையாது அப்படின்னு சொல்றாரு. சம்பந்தம் இல்லைங்கிற வேர்டுக்கு மட்டும் எனக்கு இங்கே அடிக்குது. ஒன்னிலிருந்து இன்னொன்று சுதந்திரமானது, சம்பந்தம் இல்லைங்கிறது இல்ல. எல்லாத்தையும் கம்பைன் பண்ணும்போது தான் ஒரு 3 dimensional motion வருது. You understand? When I throw a particle in space, its motion in x direction, y direction, z direction can be considered to be mutually independent. சம்பந்தமே இல்லைன்னா அந்த வார்த்தை மட்டும் தப்பு. It is mutually independent. When you combine all the 3 motions, you get the 3-dimensional motion of the particle. You understand? The combining thing is called the law of superimposition. You analyze in one direction alone, analyze in the second direction, analyze in the third direction, combine all 3 together. This can be done only when the events are mutually independent. Now let me not go into mechanics. I'm studying the motion in the y direction alone. Now there is a downward force acting. What is it? Weight. Simple. Always weight acts vertically downward. You should never forget. Weight always acts vertically downward. Even if the submarine is like this, weight always acts vertically downward. Similarly, there is another force which is acting vertically upward. What is that? Buoyancy. Now, if the buoyancy and the weight are balanced, there is no vertical acceleration. You have to be very careful. There is no vertical. Can he say there is no vertical motion?
Yes.
You think about it. You are all students of mechanics. What is the difference between there is no vertical acceleration and there is no vertical motion? See, at the point when I match the buoyancy to the weight, if it is moving already with a particular velocity in the vertical direction, it will keep on moving in the same velocity. Because Newton related force with acceleration only. When the static equilibrium exists, the body will continue its state of rest or uniform motion. Uniform motion means motion without acceleration. If the submarine, assume if it is at a state of rest, then if the weight is balanced with the buoyancy, that state of rest will continue. Is it okay? The mechanics part is, if it is moving at a constant velocity, that same velocity will continue. Now, the depth at which the submarine remains, it is achieved by controlling the weight or controlling the buoyancy. Do I have any control over buoyancy?
No.
Buoyancy force is proportional to yes. No, sorry.
Pressures.
Eureka!
Density.
I'll give you a clue.
Density.
It is
Density.
buoyancy force. Volume of?
Water
Is it
density.
volume or something else?
Weight of water.
Well, it is the weight of the water displaced. So you have a fixed volume versus The weight of the water displayed remains constant. I don't have any control over the buoyancy force. What do I have control over?
Wait.
I have control over weight. So this I showed because some 500, 600 years back, people had some knowledge. No, I often thought it should be much more because it is the Roman Empire period. So it should be. So here the idea is somebody is pushing the weight, offloading the weight, controlling the weight. You don't have any control over the buoyancy, but I can offload some weight, thereby bringing it up or taking it down. So the figure depicts somebody reducing some weight from a submarine. So that is again the idea behind having a buoyancy control. Next slide. This is the turtle, the famous turtle. This is the first successful submarine that went underwater. This is the turtle. It was made in US. It was made use of in the Civil War between the English army and the Unionists and the people who got settled in US. So it is about some 2 meters in length. In this direction it was about 2 meters, about 1 meter height, 1 meter in diameter. It is a human powered submarine. Okay, you can see somebody can sit here and then pedal the propeller. It has some lead, okay, that is used to submerge it. The lead can be offloaded by operating some levers. The lead which is positioned can be unhooked. So that is the way the submarine will resurface. Okay. This submarine participated in the Civil War. The idea was to attack a British ship called Eagle. Okay, of course, there is no British record of this, so disputing whether this is a real model. But anyhow, we have drawings and we have people who worked on it. But this is the first workable submarine that addressed almost all the issues. People can stay inside the submarine for 30 minutes. They have calculated the oxygen availability. It was designed to remain underwater for 30 minutes. There was a propeller which gave a speed. It can travel at a speed of about 4 knots. 4 knots is roughly 4 miles per hour. It can travel, if you want in kilometers per hour, 4 knots is roughly 4 into 1.6, about 6-7 kilometers per hour. It can travel underwater at 7 kilometers per hour. There are a lot of deficiencies. The structure is not hydrodynamically designed. It offered a lot of wind resistance, but still it worked. And the design they have replicated and then checked that it worked again, even today. With the same materials, they have recreated the product and they tested it and it worked well. Next slide please. Now, having seen all the past history, what are the design issues? This is what I want you to identify. What is the difficulty in designing an object that can submerge in water? The first thing is, I should have control over the depth up to which I submerge. It should not be a stone thrown into the ocean. It will submerge but it will never come back. But I want my submarine to come back also. So I have to address the issue of buoyancy. That is the control the depth at which it operates. The second important issue is air. You have seen, all of you have said. We should have that there are going to be people inside the submarine, they should be supplied with air. Then, now I am talking about modern day submarine also. See, for every 10 meters of water, approximately the pressure is going to increase by 1 bar. I told you the other day, your LPG cylinder, the pressure inside the cylinder is about 12 bar. You know, the LPG cylinder is very heavy. It is heavy, even an empty cylinder is very heavy. It is made up of a steel plate which is about 12 mm, 15 mm, 12 to 15 mm thick. 12 to 15 mm thickness is required for even a pressure of 12 bar. Okay. For every 10 meters, the pressure, the water pressure alone is going to increase by 1 bar. So if it is going to be about 1000 meters depth, up to which you want your submarine to go, which any modern submarine today, most of the advanced modern submarines can go, okay, the pressure is going to be 100 bar. You have to design a pressure vessel that can, otherwise the submarine will simply be crushed. Because of the water pressure itself, the submarine will get crushed. So, the air pressure, the water pressure, you have to address. Then there is going to be the light and vision issues. Inside the seawater, the light rays, it cannot penetrate. And so there are a lot of vision issues associated. You should know how you are traversing. You should know. You should not go and hit something. There are hills and there are many complex structure inside the ocean also. So you should have vision. The other important question that I want you to understand is power. How to power a submarine. See, the turtle was a human-powered submarine. So up to a point of time, it is human power. There is a limitation to it. Any human-powered vehicle has its own limitation. You cannot increase the speed. You cannot increase the depth. Okay. So how to power a submarine? There are many issues associated with it. We will come to it. And there are communication issues. How I am going to communicate with the outside world? Let us see. Let us see one by one. Next slide, please. Buoyancy. Now, when coming to the submarine, the weight of the submarine, it must be balanced with the buoyancy force to remain at a particular level. I have not taken the case of traveling with uniform velocity. So there must be air, there must be ballast. It must be adjusted to remain at a particular depth. If you want to go down, you add ballast. If you want to come up, you store compressed air in tanks, because after going down, you should not be searching for air. You won't get it. See, to go down is easy. What can you do? You have some pumps. You pump in the seawater. Many times, seawater itself is used as a ballast. You pump in seawater, what happens? Your weight increases, your submarine, it goes down. Clear? Now to come up, what you should do? You should pump out seawater. Please understand, now to pump in seawater is easy. Because the water is at elevated pressure, it will readily, the moment you provide some opening, you need not even pump, it will readily come inside. To pump out seawater is very, very difficult. Why? Because the outside pressure is so high. You understand? The water at 100 bar, that is the outside pressure. To pump out, you must generate pressure higher than 100 bar if you are at a depth of, say, 100 meters. So this is, you have to be, and you have to fill it with compressed air from tanks. Now, you have to have a control services to control the angle of descent and ascent. See, I want my submarine, okay, when it is descending, I don't want to go like this. This is not a natural way to go down. When it goes down, it should go like this. And similarly, when it comes up, it should. Okay, the nose must be up always when it's coming up. When it is coming down, the nose must be down. True for aircraft, true for submarine. That's a natural way to do things. So you should have control surfaces to control the angle of descent and ascent. Next slide. Air. Can you go back? I don't know. I missed some points, I think. Go back. Go back. Okay. Come. Next. Air. Now, the inside air, it should have enough oxygen content, enough carbon dioxide content, it should have enough moisture. Okay. So, oxygen, it is going to be consumed every day, so it needs to be replenished. Not only putting in oxygen, you have oxygen canisters in any submarine, you have oxygen canisters, you release oxygen into the controlled atmosphere periodically. Not only that, the carbon dioxide must be absorbed. So the carbon dioxide released, it must be absorbed using standard equipments and standard chemicals. Then the moisture content of the air should also be absorbed periodically. Now not only that, the temperature outside the sea, outside the submarine, is going to be typically, say the submarine is operating at 500 meters, the temperature outside will be around about 4 degrees centigrade. Okay, the temperature outside will be 4 degrees centigrade. So, what will happen? And please remember, what is that 4 degrees centigrade? Sir, you can come later. See, the class will be over in another 15 minutes. You can come and collect them. You leave the message with them. என்ன சார் பண்ணுமா அவருக்கு
யாரோ விழுந்து யாரோ என்கொயரி
கிளாஸ் யாரும் நோட் பண்ணிக்கிட்டோம் சார் கிளாஸ் 5 நிமிஷத்துல முடிஞ்சிடும் முடிஞ்ச பிறகு வாங்க now what was I talking about? The temperature outside is 4 degrees centigrade typically at 500 meters depth. Now you have huge amount of water. Your submarine is only. So what will happen? Submarine is now the heat source. What is the submarine? Submarine temperature? Submarine temperature will be at 28 degrees centigrade. Because that is the temperature at which we are converted. So the inside temperature of submarine will be 28. Outside you have a huge icy water which is at 4 degrees centigrade. What will happen? In no time this heat will be conducted out. And what will happen to the temperature of the submarine? That will also become 4 degrees centigrade. So I should generate enough heat inside. And I should insulate the walls so that there is the minimum heat loss or the heat that is lost is to be generated inside. And the temperature needs to be maintained. Next slide please. So the inside pressure is to be maintained. You have the outside pressure. The hull must withstand the outside pressure. So much of pressure the hull must be able to withstand. So typically you have all the US submarines with single wall and all the Russian submarines with dual hull. Okay, they have two hulled structure and the space between the two hulls, two walls is used for storing ballast and oil and all the other things. Next slide. Light. So I told about it. Okay, the visibility is very poor. You need so you have modern submarines that use camera systems. Next slide please. You have power. So the earlier submarines were human power. Now air and oxygen are required apart from fuel. If you have now this is the most important, most interesting question. Now the moment I want to have more power to my submarine, what will I do? So what would have people thought? Which came into being first? Mechanical power. Which came into being first? See, you talked about muscular power. Non-muscular power. What was the first source of non-muscular power?
Steam engine.
Steam engine. So what initially people thought was they will fix a steam engine for, that is how it could have proceeded, isn't it? They wanted to fix a steam engine for a submarine. Steam engine which will The first problem was, not only I need fuel to burn to generate steam, but I also need air. Where will I get the air? Even for my breathing, I have to take air. So where will I get the air to burn these fuels? That means it cannot go beyond. I can provide air that's from the surface, but again the submarine cannot go deeper. Again, within a small space, if I have a steam boiler, steam generator, all that, the whole temperature, it grows so high. People cannot sit along with the boiler. The space is so small, I want to have a boiler and as well as I want to have human beings be, the space is not good enough. So, steam power plant for submarine, it was ruled out. There was some initial designs, but it was ruled out because the inside heat was so unbearable, nobody can sit along with the boiler inside a submarine. Then what was the next to come? IC, internal combustion engines. After steam engines came the internal combustion engines. Now again, in the IC engines, what is the problem again? Air. Okay. So what people, even today, the air required for IC engines are the biggest issues. You have diesel powered submarines, but please remember these diesel powered submarines have to snow. What we have to do is the submarine has to come just some 10 meters below the water level, take air from the successful commercial submarines or hybrid submarines. Hybrid submarine means the propeller can work like your hybrid vehicle, the propellers can work both with the diesel engines as well as with electrical motors. Now what the submarine will do is, it will just come just below the water level, take oxygen from the atmosphere, air from the atmosphere, run its diesel engines, then charge batteries. These diesel engines will they will run a generator and charge the batteries. So all the batteries will be charged. Then it can go to the depth. Now from the batteries, there will be electrical motors that are driving the submarine. Now once this charge is over, then what they have to do? It has to come back again so that the diesel engines can operate and charge the batteries. Are you understanding the issue? Okay. So these are the hybrid submarines. No, please go back. So then came the nuclear power submarines. The only answer to all these issues are the nuclear powered submarines. The first areas next to the power production, the first area where the nuclear reactors found a place was in submarines, because that is the place where you have a compact power source, a power source that doesn't require oxygen. Okay, a fuel that doesn't require oxygen. What is the fuel that doesn't require oxygen? Only uranium. Okay, and it need not even surface to refuel. Now nuclear powered submarines can remain underwater for years together, because the nuclear fuel can be loaded for 25 years. No need for refueling. 25 years of fueling can be done at one stroke. Okay. So the nuclear power, it came as really a boon for, of course, it has other environmental issues. Nuclear submarine accidents are disastrous. That's all different stories. But from the technical point of view, you needed oxygen where oxygen is already scarce. You have oxygen only for human beings, but you are asking oxygen to even burn the fuel. So that problem is solved by going for nuclear powered submarine. Now people are talking about diesel submarine that use oxidizers, because these oxidizers were developed for rocket engines. where these rockets are to operate, where there is no atmospheric oxygen. There are air-breathing engines, as you might know. There are engines which don't breathe, meaning they carry the oxidizers also. These oxidizers were used for submarines also, and we have diesel submarines with oxidizers also. They are also now available. Now next slide please. Communication. Now all electromagnetic waves are absorbed and reflected by seawater. Almost 0% transmission. What is the meaning? Meaning is no cell phone inside a submarine. No electromagnetic wave propagation means, I was just joking when I said no cell phone. You have no means of communicating with outside world. So the only way to communicate is sonar, and that puts a lot of other problems. Next slide please. So this is a modern day hybrid submarine, okay, which uses diesel generators to charge batteries, and these electrical motors will drive the submarine underwater. Next slide please. So this is a typical nuclear submarine. You can see the size. So typically these submarines can remain underwater for years together. Next slide please. So India is also building its own nuclear submarine. It is INS Harihan. So these are the technical specifications of INS Harihan. It is not yet realized, but it might be realized in a short while. It will be realized and it might be commissioned. Next slide please. So this is the hull of INS Harihan. There are few pictures available about INS Harihan. Next. So this is in the dock. It might be commissioned very soon. Okay. Next slide please. Now I have a short video. This is a typical Russian submarine. So the maximum depth that it can go is only 500 meters. The hull is designed for that water pressure only. So this is the size. So these are the missile capabilities. I'll show you another, for 1 minute, I'll show you another video which just shows the severity of conditions that a submarine is designed for. So you is an ice-breaking submarine. Is the very low temperatures make all the metals very brittle. But in spite of that, it is able to withstand and it is surfacing. Breaking all ice, it is now surfacing. So this is the typical periscope which has to come out. So you are able to see the periscope there. That is the only way you can see what is happening in the surface. Now after seeing around, it will come up again. So it saw 360 degrees. Now it is slowly coming up again. So I just thought I should show you this because you'll have an idea the amount of severity to which these materials and the whole system can be subjected to. Now again, what I wanted you to understand in this case is what are the design issues? What are the challenges that have to be overcome? Okay, like providing oxygen for burning or a communication where you don't have any electromagnetic wave propagation possible. Okay. Or you want to have extreme pressures that are to be withstood by the material. Or the temperature to the extent of minus 0 degree centigrade or minus 4 degree centigrade or plus 4 degree centigrade. So such extreme temperatures are to be destroyed. So these are the design issues that you have to clinch and address while taking up any design problem. Thank you.